Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Very good. Today's session, we're going to be talking about an Azure OpenAI Service incident that impacted on the 13th of July. One of the reasons that this got so much attention and why we're bringing it to this forum is it was a multi-region incident. It impacted 14 of the regions that Azure OpenAI runs in, which is about half of the regions, which is a big deal. So we want to talk about what happened and what went wrong.
And with us today is Chris Basuglu, our Vice President of Cognitive Services and our AI platform. Welcome. Thank you very much for joining us, Chris.
Hi, nice to meet you.
Chris, there's been lots of people talking about OpenAI. It's in the news, it's in the media. Could you help us just to orient ourselves initially? What's Azure OpenAI Service and how do customers use it?
Right. So, as you're aware, Microsoft has a deep partnership with OpenAI. As a part of that partnership, Microsoft has the rights to host all of the OpenAI models. That includes like GPT 3.5, GPT-4, GPT-4o mini, all of the models that OpenAI makes available to their customers. Microsoft has a right to make those same models available to our customers. And given Microsoft's gigantic enterprise customer base and enterprise knowledge space, we as Microsoft felt that we could make all of the OpenAI models available through an enterprise enhanced offering, which we call Azure OpenAI Service. And it has all the same features, all the same accuracy, all the same functionality as the OpenAI APIs do. And we ship those with parity, but with additional enterprise security, functionality, and enterprise promises, that Microsoft makes that our customers trust Microsoft to deliver, and so that's the basic difference. Same models, same functionality, but with the kind of the Azure promise that only Microsoft can make.
That's wonderful. Thank you very much, Chris. It's interesting to hear about the parity piece. But before we get into the actual incident itself, one of the key actors in this was the internal automation system that we referenced in the PIR. I was hoping you could talk to us a little bit about the characteristics and what this does, because it was interesting to hear that in some aspects it's regional, but in some aspects it's global. And that played a role in this.
Yeah, so I think, in the operation of any large service, including Azure OpenAI Service, there's usually some underlying automation that's handling deployments, that's handling cluster build out, that's handling different file uploads and control plane operations that the customer might make. And Azure OpenAI Service is no different in the sense that we have an automation that does those things. In our case, that automation handles all of those things. The same automation handles all of those things. Cluster build out, GPU scheduling, fine-tuned file uploads, and as well as moving data back and forth between different workspaces and things like that. And so the automation that we use in Azure OpenAI Service is basically what we call goal state oriented. So either when the customer themselves, let's say, creates a new fine-tuned deployment, for example, or we decide to bring up a new region or bring up a new model, we will change either through the customer interactions, the goal state will change, or we as engineers, if we need to do something manually, we'll change the goal state, and that goal state is then compared against what's actually in production, and the automation will try to make what was set in the goal state the same as what's what's in the cloud. And in this instance, this automation was involved.
Got it. That's a good teaser campaign here. I'm interested. I'm not sure if you kind of clarified the regional versus global point, so that this automation system exists in every region, but it tries for some global consistency. Is that right?
Yeah. So the automation, as you said, is independent in every region, but the goal state can be global if the goal state is modified in a global way. So in the one goal state, you can specify multiple regions. You can say, delete this file in this region and delete this other file in this other region. And you can modify the goal state and let it go, and it will go try to do that at the same time. You can also just change the goal state one region at a time if you want to be more safe.
Got it. That makes sense to me. So now we can fast forward to the 13th of July, which is the incident we're talking about here. But we mentioned in the post-incident review that something went wrong and that it was to do with this accidental deletion. So can you help us understand the ways in which that automation system interpreted or misinterpreted, a call to delete something and ended up deleting something that shouldn't have been deleted?
Right. So to start out with, Azure OpenAI Service, basically, at a very high level, it's got front end endpoints, which is the endpoints that the customer calls, and there are resources to back up those front ends, and then there are back ends. The front ends then call the back end, and then there are some internal resources that represent the back ends. In this incident, the automation that we've been talking about stores, several resources, together in resource groups. And there was a issue where we were hitting some storage account quota limits. And we wanted to do some kind of routine cleanup to delete some storage accounts that were unused or unneeded. And then that would help us kind of reduce our hitting against this quota limit. So yeah, the issue started out as kind of an engineer doing something that was needed to delete these unused resources, storage resources in this particular case, to help us reduce against this quota. And the way we did that was, we told the automation essentially delete these particular resource groups, and we told the automation delete these 14 resource groups in these 14 different regions within this particular subscription. And normally, the automation, which would know about all of the resources within the resource group, right? The resource group is kind of like a directory, and the resources within it are kind of like files. And the automation would know about these individual files within the resources within the resource group, and would be able to safely delete them, because it would know that, okay, this was part of the goal state and these are no longer in use, and it's safe to delete both the resource group and it's, when you delete the resource group, it's fine to have all of the resources underneath it be deleted. What happened in this case is, over time, there were other resources added to these resource groups. Again, like a resource group is like a directory, so think of it as some other files were added to this directory, but they were unknown or unregistered to the automation. So the automation, it's like they didn't even exist. The automation didn't even know about these other files or other resources. And so when the automation went to delete the resource group, it deleted the whole resource group, and everything in the resource group got deleted. Resource group didn't know about these other resources, but they got deleted, and it turned out that these other resources were essentially resources that represented all backend endpoints. So in each of those 14 regions, essentially all backend endpoints started to get deleted. So they essentially disappeared. Customers, the front ends, were in different resource groups, different areas. They did not get deleted, so customers still saw their endpoint that they used, But when they tried to use those endpoints, and then those front ends then turned around and wanted to use the back ends, those back ends weren't there anymore. They were deleted, and our customers started to get errors.
Chris, when I think about we made a change like this, it has impact. Am I naive in thinking, is there a soft delete? Is there a Control Z option where we can undo this change? Or once we delete something, is that it? We have to start kind of rebuilding and rethinking this? Help me on, like, it's a big change.
Yeah, I think essentially the recovery was like a soft delete in a sense, in that once we realized that the deletions were happening, the first thing obviously we did was try to stop the deletions kind of dead in its tracks in the middle, and then once the things were deleted, the way we recovered, just like within a soft delete, is we essentially ran another kind of automation that restored, brought back the deleted resources. Now, normally in a soft delete, it comes back like right away. In this particular case, the things that we were restoring that were deleted had to be copied back. So the models here, the OpenAI models, are very large, as we know. That's what makes them so advanced. Is that's why they're called LLMs, large language models. They're large, and when we essentially hit the automation button to bring everything back, we did so in parallel. So each region was restored in parallel, in each different model type, like GPT-4 versus GPT-4o or GPT 3.5 were restored in parallel. But within each model type, each individual customer deployment, it was restored serially, and that's what took the long time. But from a high level, you can think it was just hitting one button to say restore everything, and for the most part, and we'll talk about some of the exceptions, it happened. It restored itself automatically. It just took a long time.
On that piece, because the bulk of the outage kind of was within a 24-hour period, but then there was some fine-tuning, and you kind of alluded to it now, that took a little bit longer. What was different with the fine-tuning? What were the attributes? Why did that piece take a little bit longer and kind of outside that main mitigation window?
Yeah, I guess as part of that, which models and regions and what took longer, what was the kind of long tail recoveries here for extra customer pain?
Right. So, like I said, the main chunk of the models kind of came back automatically. It just took a long time to do, but there were a few instances. Fine-tuning is one, GPT-4o is another, and DALL-E was the third one, that required some extra manual intervention. They didn't restore automatically with the hit of the button. They tried to, but it didn't. So let's talk about the fine-tuning one first. That's the easiest one to explain, which is, I mentioned before, one of our first mitigations was to try to stop the delete dead in its tracks. So when at the beginning of the outage, we were fearful, we didn't know everything that was going on at the beginnings. We were fearful that it might delete all regions. We didn't know it was going to stop, that the goal state was, limited to 14 regions. We didn't even know it was due to the goal state at the very beginning. So our first priority was to stop the delete dead in the tracks. One of the ways to stop the delete is we just stop the automation. We also, talked with the Azure ARM team and tried to stop ARM for these deletes and a bunch of other things. But in stopping the automation, as I mentioned before, the automation, not only does it control like cluster build out and service build out, but it also, that same automation is responsible for when a customer wants to do fine-tuning and they want to deploy a new fine-tuning model, a new fine-tuned model, which is specific to them. That automation is the one that copies the fine-tuned model over and sets up the endpoints for those fine-tuned models. So since we disabled the automation, that also disabled deployments of new fine-tuning. This particular incident happened over the weekend. It started Friday night. So later Friday night we stopped the automation. We did not want to turn it back on over the weekend for fear that more deletes might, continue on. We convinced ourselves that, we had, that no deletes would happen, but we wanted to be very cautious, and we didn't want to, after recovering everything, we didn't want to turn the automation back on and then have it just delete everything again. So we wanted to wait until the Monday morning, where everything was fully recovered and working well, and we could analyze things more carefully. And then we turned the automation back on, and that restored fine-tuning. The other ones that took a little bit extra manual intervention for GPT-4o. GPT-4o, as you know, is a multimodal model. It has not just text, but image, and soon we'll also have speech, as has been announced by OpenAI. And because of the multimodal interactions, there are several pieces to the service that need to come online and work together, and that includes various communication streams between the multimodal pieces. And the automation brought all the pieces back, but when they came back, they were not initialized properly in a way that they just started working together. So that it required manual intervention to get all of the multimodal pieces working together in a proper way. We did not expect that. That was unexpected. So we had to bring in some experts on some of the dependencies, some of the pieces that are dependencies in other teams, to go look at why that didn't happen. So that manual intervention took extra time. And DALL-E, in a similar case, the internal design of DALL-E had been recently changed to move the internal pieces more to managed identity authentication. And there was some whitelisting that had to happen for those managed identities in DALL-E, and those identities were not whitelisted. So when DALL-E was brought back automatically with the managed identity, it did not work because we had to go manually add these managed identities to the whitelist.
Got it. That's a very thorough accounting of kind of what went wrong and how we mitigated it, including some of those areas that took a little longer. I'm interested, if we pivot towards kind of our retrospective and looking back on it, what did your team learn? What are the repair items that fall out of this? I know we'd talked about changing some of our configuration policy, but it really strikes me that safe deployment or something that looks like safe deployment practices to make changes kind of slowly and cautiously in an ever-increasing scope would have helped here. Could you talk us through the learnings?
Sure. I mean, I think there are several repair items that we have talked through, and many of them we've already implemented. It's been about 2 weeks since the outage, so we've had already 2 weeks to implement some of them. So the ones that we implemented immediately. One, of course, we addressed the knowledge of the automation. So now we've made it so the automation does not know about these resource groups at all that have these backend endpoints. So we've removed these particular resource groups from the knowledge of the automation, so it cannot do this anymore. That was the very first thing we did. The next thing we did is we implemented, as you hinted at, we implemented several policies that require updates to this goal state to be regional. It's still a global state, right? So someone at this point, at least before further repair items, at this point, someone malicious could go in and try to do multiple regions at the same time, but by policy, that should not happen. We do have a new version of the automation that's coming online, where not only will it be by policy, the SDP, but it'll be by design, that even if someone wanted to try to do this kind of delete or this kind of a change globally, they would not be allowed. It would not be possible to do so. But in the last 2 weeks, we've already implemented, at least by policy, that it cannot happen. We've also added several tests and checks for when someone makes changes to these goal states. This goal state is done through you check in the goal state. So before you can check something in, there is some validation that would prevent things like this from happening. There are several, 20-odd different repair items that we've also posted, that we are working on now. So those 3 that I mentioned, we've already done. And those include, and we can talk about this later as well, like faster recovery. I mentioned, we hit a button and we just had to wait for a while, because of the model copy. There are several repair items on, getting the recovery to, if this were to happen ever again, which hopefully it never does, this recovery to happen much faster. Off of the single button. There are repair items to go after those manual things that we had to do, like for the GPT-4o to fix, if GPT-4o is ever recovered like this again, that it would come up automatically instead of requiring manual intervention. And same with the Dolly. But there's a whole host of repair items that we've identified that we'll work on.
So thank you very much, Chris. I especially thought it was interesting around the moving from a serial way to a parallelized way of doing build-outs to expedite recovery. One of the things that we mentioned, though, and we have our learnings and repair items, but then we say, what could customers have done? And one of the line items I couldn't help notice was to say, if customers had multiple endpoints, then they could have reduced the risk of an outage or impact. But I think we had 14 regions that were impacted. So you would have had to have multiple endpoints, not in the 14 regions. Is that a big ask for customers? I mean, is that a huge cost to sit down and say, deploy multiple endpoints? And is it costly? How should customers interpret that?
Yeah, I think Azure OpenAI Service, as well as a lot of different Azure services, have a pay-per-use model. So and a large majority of our customers are using Azure OpenAI Service through the pay-per-use model. So it's not a great cost to have a deployment in multiple regions if the majority of the traffic is in one region and the other regions are essentially sitting there for disaster recovery purpose, that a customer would be able to deploy pay-go deployments in, let's say, 10 regions, 20 regions if they wanted to, and they wouldn't pay extra for having those deployments if they weren't if they weren't sending traffic to all of those 20 regions all at the same time. And so it would be feasible, and we do have many customers who do this, who create multiple deployments around in multiple regions, and they are and they have some in their own internal routing from their own applications to be able to flip from one region to another based off of whenever they would like to, whether it's due to an issue from us or due to an issue from some of their dependencies, or they want just extra capacity. There are many reasons why customers do that, and that's a common pattern. So it's not a big ask to do that. I think for those customers who use our reserved instances, or what we call PTUs, those are kind of paid for upfront, and so that it would be, if you're not going to use those in different regions, then that would be a cost. But even then, some of our customers just divide their traffic across multiple regions, and then if an outage happens, then they'll move all the traffic over to one of the multiple regions.
That's a great explanation. I like the idea that those, endpoints in multiple regions, that's probably helpful for most incidents. We're given that most incidents are limited to a region or limited to a zone. It's very rare that we would have an incident like this that impacts so many regions. So good to know that there are options available there. Chris, that's a great kind of summary of the architecture of what went wrong and of what we learned. So at this point in our sessions, I generally like to turn things over to my co-host. Sammy runs our Azure comms team, so I'll ask him, how did we do? How did we communicate with customers? Did we keep people up to date? What do we think?
There's definitely room to improve. One of the things that we have in our comms ecosystem is something called impact analysis. And what this typically is if you think about what are the virtual machines running in central US on this scale unit, and we know the subscriptions that are deployed there or subscriptions that have resources there. For storage and compute, those are physical clusters. When we think about web apps and so on, they become logical. And so for every service in Azure, we know which subscriptions have deployed which resources, and that's kind of automatically fed in. So if we need to communicate to all Azure OpenAI subscriptions within a certain region, we're able to do so. Because Azure OpenAI, we haven't onboarded them yet, which means we're not ingesting those subscriptions into our automated system, which means during this outage, when we sat down and said, these are the multiple regions that are impacted, if it was another service, we could select the regions and say, dear Mr. and Mrs. Customer, we understand you're impacted. This is an us problem, not a you problem, and we can work it from there. While it took us time to get the impacted subscriptions, we spent too long kind of deliberating on the best way to communicate. And so we ended up going to the status page to broadly communicate, which was probably the right thing to do because this was a multi-region outage for Azure OpenAI services. But additionally, we over-communicated this to the subscriptions. We couldn't quickly ascertain which customers were in which region. And so we ended up communicating to pretty much all customers. So many customers wouldn't have seen any impact or they wouldn't know what's going on, but they would have received our communication. And this is because we over-communicated. One of the key repair items that we have is to make sure that we can onboard them into our automated system. Once they're onboarded onto our system, it gets easier to implement things like Brain. Brain is our automated communication mechanism that can communicate to impacted customers within about 15 minutes. Here we had large delays because when humans are involved during the fog of war, trying to understand what's going on, we experience delays. So overall, I think there was the communication experience for our customers. It wasn't stellar. There's room for improvement, some of them around tooling. And then once we have that impact analysis, we can start building on top of that with things like our Brain service.
I'm glad, but Chris isn't the only one with learnings around here. So the comms team has some work to do. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure Well-Architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.